today we'll talk about presenting data in quantitative research, presenting numbers. How do we present numbers? I mean, we have a pretty good idea because we've spoken a lot about that. But this is a little more formalized presentation of how we do it. And I'll have a couple examples. I'll pull up an Excel sheet and show you how to make graphs and charts. Now, how many of you have done any form of graph or chart taking in your past? Any of you made charts and graphs with Excel? Steph says yes. Arthika says barely. And the reason I'm asking this question is I want to know where I can start from. So it's good. No, I haven't. Thank you. That's perfect. Okay, good. This is good. So we can start from scratch and build the way up. And I know this is so making a chart isn't on your syllabus, but I think in this day and age, just a refresher, you may not, if you don't use the methodology like I'll teach you today, you'll maybe practice a couple of times and then 6 months from now, you're not going to remember it, but that's okay. It's just the more you get sensitized to it, you have a sense for, well, this is possible using this particular software. So, you're a little more comfortable going and attempting something if you had to ever make a chart or a graph or something like that. So that's the whole point. So let's get into the lecture. I'm going to go ahead and share my screen. Yeah. So and like Steph points out, she forgets the procedure. There is a methodology to it. I guess someone has a list of things that you need to do before you do it, but I'm self-taught, so I don't have that list. I'm just going to tell you what I do. Okay. Let's go and share that. Okay, let's get this going. Presenting quantitative data. Okay. So even when we present quantitative data, oftentimes there are reasons for excluding some data. When do you think we might exclude data from a set of information? Let's say we're looking at surveys and we're collecting numerical information. Are there reasons when we might exclude data? What are different reasons that we might have? Go ahead, Steph.
I was thinking when we suspect there's been some kind of flaw in collecting data from that particular, I guess for that particular unit of analysis, like maybe if we were doing an attitudinal survey and we suspected, hey, this person was, being kind of a monkey and was fooling with the results or something like that.
100%, yeah. So one of the strong reasons, and Steph has mentioned the term unit of analysis, and we haven't touched upon that yet, but we will. So if we suspect that, there's this data that's come out of someone messing around, you don't use it, you discard it. Other situations where we discard data sometimes is when, for example, 1 second, let me just admit the student in. So I'm going to just pull up an example of when we might exclude data. I'm going to just do a different, we don't need to do that. Okay, so I'm going to share this Excel file. If you can see this Excel file, so this is what I'm at the moment, I'm working with the local hospital because they have a bunch of anesthesiologists and they're trying to determine with which procedure do they find that the patients feel they're well communicated with from the physicians, and they're looking at patient care and their satisfaction. So all these color codes, so you see red, you see a weird kind of yellow, you see a kind of magenta here and some green, some yellow again, some green, different shades. So it's color coded with different kinds of procedures. Now the issue here is sometimes, like in this whole thing, it's about 250 data sets or units of measurement. But there are stuff that I will have to discard, and the reason for that is some of the specializations, they only have 3 procedures. So oftentimes when you have for each individual category, if you have less than 5, you really can't use it for any proper statistical analysis. So it's recommended that you discard them. There are ways to use very small samples, but it requires a lot of statistical compensation, and then it becomes one of those difficult to justify data sets. So people will avoid or ignore that data in that circumstance. So in quantitative research, those are some reasons why we might exclude data. So this is a chart from your textbook. This is an example of raw data. So you are, let's say hypothetically, you've surveyed 30 students and you're getting the number of hours they spent studying, and you compare their examination mark. You look at the sheet, and if I asked any of you, take a look at the sheet, take a few minutes and tell me what the correlation is between the number of hours spent studying and the examination result. You can do it. It's going to take you a considerable amount of effort. And the reason is, well, even if you're really good at data analysis and good at revolving numbers in your head and doing some quick totals and quick averages, the problem with this kind of a setup is this is a data summary form. So it has summarized the data that you have from, say, 30 students. So you don't have 30 sheets, you have one sheet. But the problem is it's not organized in a way that you can get to the answer quickly. This doesn't tell you anything, right? It's useful to someone who's amazing with raw numbers, because when you look at it, the number of hours they're not organized in increasing or decreasing fashion. The raw score also is not organized in any significant fashion. Yeah, you might get excited looking at 98 and 99 on top and smaller numbers at the bottom, but when you scroll down the list of numbers, there's actually no order or pattern to the whole thing. So very early on, researchers found out that, well, you can't really use this. So then they codify. It's a summary form. Then you codify the data. So what you do then is you create code. So if you look at this, next to each person, you can say let's say the average number of hours studied. So you can make an average of all of these numbers. Let's say the average number of hours studied is 20. Anyone that studies over 20 is considered above average hours. Anybody that studies below 20 is considered below average. And then you can codify. So for each student, so for example, student number 1, you can write, you know what, I'm just going to get my iPad. It's easier to do it with a pen and an iPad because I'm just saying stuff and it might not all be sticking. So let me just do that in a second. 1 second. Okay. Okay, so here's what you can do. If you have a data summary form like this, what you can do is you can just go ahead and say, well, this is above average hours, this is above average hours, this is below average hours, this is below average hours, and you can do this for the entire sheet. What that then lets you do is, so this is just an example of how they've coded per student, just like we spoke. And AR is above average result, BR is below average result. If you do that for the entire table, then it's easy for you to add the number of students who are spending above, or the result is above average, and have they studied more than the average amount of hours, or have they studied below the average amount of hours, and so on. You can easily categorize this. This form of data presentation is called a tabular presentation because it's a table, okay? And you will notice that once again, this variable is your independent variable, and this is your dependent variable. So this is almost like a protocol or a procedure that researchers follow. Even when you're making tables, your independent variable tends to go along the x-axis and independent goes along the y-axis. It's not horribly wrong to do it the other way for tables, but people typically follow these guidelines. So again, so an intermediate step before this is before you get to filling these boxes out. If we go back to this and we go back to, whatever this is number of hours, so we go above average hours. Oh, sorry, this is below average, below average. So, you have one of each type. You're going to have to add them up to find out how many, right? So when you add them up, you can put a check mark next to each above average and below average. So one check mark represents one incident. So you get to total up the relationship. And now once you have that, you can represent that as numbers. So what you can do is you see numbers. This now 11 is the number of students that scored above average on the exam, but they also spent above an average amount of hours on study. So you can see that there are 12 students who spent below the average amount of time on study, and they scored below average as well. So the meaning of the term frequency is the number of times a certain incident occurs. That's what a frequency means. So the frequency of students scoring above average mark is students who got this and students who got this. So it's about 13 students, right? And the frequency of students who scored below average would be about 17 students. Okay, so this plus this, it's about 17 students. Okay, what they're trying to show you also in this table is something called marginal totals. Marginal totals is, that the number of students who scored above average is a total of 13. So the number of students who spent above average time studying or below average time studying, but they scored a high mark, their total needs to be 13 no matter what. So you total them on the side and you should get 13 there. And for below average, if you have 13 students who scored above average, then there are 17 who scored below average, regardless of how much time they put in, but the total should get you to 17. So that's how you get 13 plus 17 makes 30. And the same way, this is looking at students who spent time studying. So there are some students who did spend a good amount of time studying, but they did not score very well, and that would be a 5, and the vice versa is true, where they spent very little time studying, but they scored above average mark. But those are the exceptions. For the most part, if you spent more time, you got more marks. But the important thing is if you scored above average, you have 16 students who scored above average, you have 14 below. And if you add this and this up, you still get to 30. So these are called marginal totals because you're totaling them on the margins. And it's more of a mathematical accountability. It doesn't sound like a big deal in this example because your sample size is just 30. But think about the Excel sheet that I showed you. It had about 250 samples. Now, I don't want to really miss anybody. So when I'm presenting my data as a table, when I do my marginal totals, I better get 254 or whatever it is. The actual sample size that I have to work on is 786 samples. But unfortunately, when I put all the 786 on my Excel file and try to do any kind of analysis, it crashes. So I'm working in sets of 250, which is a pain in the rear end, but it is what it is. Anyway, so that's what we have about marginal totals. Keep in mind, just to take a step back, you have absolute raw numbers here being represented. You have 30 students, you're accounting for 30 students, it's right here, okay? Now, this is pretty good representation. You can see that most students who spent above average time studying scored an above average mark, and the same holds true for students who scored below and so on. Now, you might not want to present actual numbers. You might want to present a percentage, because percentage makes more sense. 30 is kind of an odd number. So it's sometimes harder for people to visualize what 11 out of 30 is. Well, how many percent is it? What percent is 12 out of 30? Is 12 out of 30, how much more is it than 11 out of 30? So people will often use percentages. So what they'll do is the same exact example. Instead of going with absolute numbers, they will specify, excuse me, on their table that n refers to the number, total number in the sample. With an n of 30, which is 100%, they will tell you that students that spent above average time studying, so 36.6% of the students scored an above average mark. About 40% of the students who studied below average hours also had a below average mark. And the exceptions, which are students who studied very hard but scored poorly, is a 16.7%. And the students who were exceptionally bright, who had to study very little but get above average mark, is your 6.7%. Now, it's all the same thing. It's just different ways of representing it. But what percentages does is percentages are particularly valuable if you're comparing two classes, looking at study patterns and marks. And basically what you're trying to do is you're trying to determine if there are differences between the two classes, but the size of the two classes is different. Say one class is 30 students and one class is 40 students. So the absolute numbers no longer make sense anymore, because you might have 16 students in the class of 30 who score very well, and you might have 17 students in the class of 40 who score really well. So how do you compare the two? So that's when you start talking about percentages, because percentages kind of uniform everything out. Now, what you can do is you can also, there's an additional complexity that you can add to it. So you can calculate it a little differently. You can say, instead of talking about absolute percentages, you can say the percentage of students spending an above or below average time. So what you can say in this exact same example is you can say 68 point, let's say there is a certain average mark, okay? So 68.7% of students scored above the average, okay? And 31.3 scored below the average. And what you're doing is you're just splitting up the above average. You're considering the total of this as 100%. You're considering the total of this 100%. And then you're simply splitting those two up. So your 100% is an n of 16 and your 100% is an n of 14. And then when you split it up, the proportionality is a lot more students, if you want to compare, a lot more students score above average mark when they spend more hours of time, so it's more than double. But if you look at the students who actually score below average marks, you find that it's almost 6 times, 7 times more. So the impact of studying less is far greater than of students who are not succeeding because they're studying more. So if you wanted to make that kind of an argument, then you reorganize your data this way. So there are many. The point of all of these exercises, if you look through all the tables, is it depends on what the argument is that you want to make, and you can readjust your numbers. They're all the same numbers. They're not different. So you're not making things up. They're exactly the same. It's just a different way of talking about all of these numbers, even when you use percentages and so on. Okay. I'm going to pause here for a second in case you all have any questions, because I know we ran through like 3 or 4 tables really quickly. So I'll take a minute and let me know. Okay, seeing none. Now, you might have all kinds of numbers, but and tables are great for representing data. But a picture is really worth 1,000 words. There is no question about it. And graphs have a lot of value. So the same data when you're talking about students who, so, you have a graph and you talk about hours, which is your independent variable. And then you talk about the mark, which is your dependent variable, or number of students getting a certain mark. And since you've divided, so this is the actual number of students scoring above average. So you're only asking the question, well, we have students who studied more than average or less than average. So you've made that essentially a categorical variable. So you converted the above average and below average, you made this a categorical variable. And then you're asking, well, how does this categorical variable change, or how does the variable change depending on the number of hours studied? So when you look, or the actual numbers, how do they score on an exam? So when you look at this graph, what happens is you have 11 students who studied more than average. So you have a total of 16 students who studied above average. Of that, 11 scored above average. 11 got a high mark. So these guys did good. And you have 2 students who studied less than average, and they are represented by this bar. Okay. This is an incomplete picture, but we're simply asking the question, how many scored above average? And how much did they study? So when you divide the study into above and below, you made that categorical, and you're just counting numbers as to who scored above. Now, because that's an incomplete picture, the graph can also be modified. So these kinds of graphs are called bar graphs. Or histograms. Okay. This is a more representative graph because what it does is, if you look at this graph, if 0 is your average, this is your average. Okay. We have a total of 16 students here. 11 studied more than average, 5 studied below. 16 studied more than average, 11 scored higher, and 5 scored below average. There were a couple of students who studied below average, but they scored a high score, so they are highlighted here. There were a whole bunch of students that studied less, and they also got a less mark, and they're represented by this darkened box here. So this graph is more representative because you have the complete picture of all 30 students. Okay. Again, like I said, just as with the tables, the bar graphs can be represented in different areas. This is like a shaded area plot. And what they do is the size of the box has a percentage in it, and so they represent by percentages. So this percentage of students who studied more than average got marks, above average marks, and this percentage of students, despite studying less, got an above average mark, and vice versa here. So on. So this is the percentage method to use, like a plot, or it could be a bar graph as well. If you had a percentage scale drawn on here, you could have a percentage scale here as well. With this being 0, 10, 20, 30, 40, 50, 60. And same here. So you can plot it as a graph, but even as a box and an area, a graph, you can go ahead and represent your data. It's just important that when you look at data of this sort, you just, don't depend on the words. When you look at the graph, start thinking about what they're trying to show and which one's going up, which one's going down, what's the dependent variable, what's the independent variable, and so on. Okay, and this chapter is all about describing different ways of representing or presenting that quantitative data. Now, this is called a pie chart. A pie chart typically represents proportionality. Okay, a pie chart doesn't does not, and remember this, does not represent independent variable, independent variable. It's not doing that. That's not the idea of a pie chart. A pie chart's objective is simply to show you proportions, to show you how the distribution is. So for example, if I wanted to talk about students in different age categories in my research methods class, and I split it up, 20 to 30, 30 to 40, 40 to 50, and 50 and above. And so for that kind of a question where I'm seeking to simply split the class up into, it could be anything. It could be age, it could be ethnicity, it could be whatever we pick. That kind of representation would be a pie chart. It's not speaking to a relationship of any sort. So this kind of a representation is called a scattergram or a scatter plot. Okay, and what this does is if we don't feel like summarizing the data like we did on the tables before, and we want to actually plot each and every student, you can do that. Okay, lots of people are interested in looking at trends and they don't want to really summarize the data. So you can plot each student. So you can look at student 1, you can plot their number of hours that they spent 30 and they got almost 100%, and student 2 and so on. So you can do that. And if you have 30 students, you might end up having 30 different dots. They have 5 dots here. You can, I'm just making pretend dots all over the place. You have and lots of times what will happen is when you look at the dots, you get a pretty good sense of what's going on. The more hours you study, the more marks you get. So there's a linear relationship. You might not be able to draw a straight line through all of them because, there is some variation due to difference in people. But you have very good software that will draw something called a trend line, which is a best guess of the relationship itself. It uses something called regression, linear regression. Again, these are things that you might see when they talk about regression analysis. So what it'll do is essentially it'll condense the relationship of number of hours to exam results and stick it into a line. It is an artificial line because it may not connect with any of the points, but it kind of shows you the relationship that, well, the more you study, the more marks you get. Now you have to remember that there are exceptions. There are some students who studied very little and got a good mark, right? And that's okay. The trend line does not say that these points can't exist. It just takes the overall average of what to expect in such a situation. So these graphs are typically linear graphs. And in this case, for example, they're looking at different tiers. This is from Citizenship and Immigration Canada, also in your textbook. So they're looking at number of permanent residents. They're looking at different years, and all they're doing here is they're just taking absolute numbers. There was a certain number of immigrants that came in 85, 87, 89, 91, and they're just connecting the different dots that come on. So you have total number of immigrants. Yep, so this is pretty straightforward, nothing much to explain. They stick all the dots there and they just draw a line through the whole thing. Okay, so these are linear graphs, or called line graphs as well. Line graphs can, there's depending on what kind of data you're collecting, there may not be a very specific pattern to anything. You're just trying to get a sense for whether things are going up or down. So this is a line graph depicting the increased number of hours spent on housework because of presence of child at different ages. So when you have, and this makes a little bit of more sense. When you have a very young child, your housework is higher. About 1 year, it's a little bit less. 2 to 5 years, a little bit less. 6 to 11 years, a little bit more work. and 12 to 17 far less work because the child is more independent. Now, yeah, you can say that it's not necessarily linear because it's linear to a little bit and then the linearity changes, but it depends on the sample size, and the overall trend is it is going down. The overall trend, if you plot the first point to the last point, is over time the amount of work that you have to do decreases. Okay, and again, this is taking the example of a single child family where the child doesn't have other challenges and so on. But if this was done using a lot of averages, this is the kind of graph you'd get. Again, different kind of graphs, and the whole point of this example that your textbook makes is to pay attention to the scale. So what they have is the same graph. If you can believe it, these two are the exact same graph. Why do you think they look so different? Okay, Steph, and then Artika.
I was just going to say because the scale on the y-axis is so much different.
Right. Artika, do you want to say why the change, why the difference in scale has flattened the graph out? What do you think is happening?
I was gonna say the same thing. I guess it's the y-axis has a larger, I don't know what the term is, but not variables, but the scale is different.
Exactly. So, I mean, the distribution of numbers on the y-axis, right? Because you can have very sensitive graphs with, if they'd split this number by instead of 1000, 1050, they could have gone 1000, 1001, 1002, and then this graph would have looked even more dramatic, the first graph. Okay. Because the scale is different, this looks far less muted. So this is the other thing that we have to always be cautious about when we read newspaper articles. Watch the scale. Watch the scale. Sometimes people will say, well, there's been no change in median income for residents of Sudbury over the past 10 years. You want to ask, well, what scale are you using? Because often what happens is journalists are not statistically or skilled in research methods. They will present what is told to them, and researchers know this very well, especially the ones who want to influence policy. So oftentimes they won't talk about the scale. They'll just tell you, look at what's happened, and they'll show you these amazing presentations. You look at this going and you're like, oh my God, I mean, there was a massive spike in hate crimes in 2011-12, and then it went down dramatically in 2013. So that was amazing. You look at this graph, it stayed the same, right? So it's just a caution to pay attention to the scale. Again, pay attention to the scale. So you have city B and city A. It looks like city A has been increasing its budget for the environment every year. It looks fantastic, great slope. On the other hand, city B, they've hardly increased their budget for the environment. But when you start looking at the scale, look at the scale for city B, it's in the millions. So this small increase, because they're scale, so let's split this little thing into 10. Let's assume that's 10. I could only draw 6 ticks. My dexterity is not that fantastic. But if you just took 2 points in time, let's say here, and let's say here, that's still 150,000, okay? And if you look at 2 points in time here, it's about 100,000. So actually, city B is spending more than city A, but the graph is all messed up. Okay, so this is again, good researchers will try not to confuse people by presenting these types of graphs. The whole point of presenting a graph like this is to compare to city spendings, right? You're comparing city B versus city A. Is this a fair way to represent data when you show this? It almost, to me, it looks like an effort to mislead, right? Because you're trying to let people process information quickly. That's why you present the graph, you present the picture. Even as researchers, when you look at it, if you are not like really looking at stuff, it looks like one city does better than the other, whereas the converse is actually true. To be absolutely fair, the way to present this is maybe a percentage year-over-year increase, because you can argue that, say, Toronto is a massive city with a massive budget, and how can you compare it to, say, a smaller city like Sudbury? Okay, well, let's look at the year-over-year annual increase in percentage, and then you can put them both on the same graph. But very often when people present graphs, especially city planners and stuff, they will present graphs like this. And then you have to really look at the scales, and you have to think, well, is this making sense? Okay. So this is a different kind of line graph, and they're comparing. So it's possible on a line graph to have more than one dependent variable be measured against an independent variable. So in this case, you have, say, the phone calls received by 3 fictitious Canadian counseling services, service A, service B, service C. Each one of them represents a dependent variable, the dependent variable being the number of phone calls received. And they're representing them differently. You have a solid line, you have a dotted line, and you have a dashed line. So you're able to do that. In this case, in this example, this, the whole point is to show you that you can represent multiple types of, not multiple types, multiple dependent variables on a dependent-independent scale, as long as you code for them differently. And that, this is quite common. We often see that. If you're into any kind of investing with your savings or money, then you often see that when you go up and you compare how your stock portfolio did to something else, you kind of look at that on a map and so on. Okay. Okay. Finally, we talk about averages. Why do we pick an average? Well, what's the whole point of an average? Or let's make this example more tangible. On average, so when I say on average, my students score 75% on an exam, what am I saying? And let's say there are 2 professors. One professor says, my average student score on my courses is 75%. The second professor says, oh, my averages are a little bit higher. They get about 80% on average. Why are they talking about averages? What's the whole point? Steph?
I'm just thinking averages really only become meaningful when you're comparing them to other averages. So it does allow you to compare your performance. Like, I mean, it's a debatable measure of performance, but a performance between, 3 different classes at Laurentian, for example.
Thank you, Steph. Yes, exactly. It's an average it's a snapshot. And it's a meaningful snapshot only when you're planning to put it against other snapshots. An average in and of itself, it doesn't tell you much. And even then, depending on how you pick the average, it's the crudest comparison model for 2 samples. Okay, it's a very, so for example, like Stephanie said, it's not a great model to talk about a comparison using an average. So telling, if professors are having a discussion and they say on average my students get 75%, what they're saying is if you picked every mark of every student, you added them all up and you divided them by the total number of students, it would be 75. They're not accounting for the students who get 100% on the exams. They're also not accounting for the students who get zeros on their exams. Okay, so so you really don't know how the class is doing. So the average is tricky, but you have to remember there are different kinds of averages. There's the mean, there's the median, and then there's the mode. The mean is what most people consider the average. Or when they talk about average, they're talking about the mean. The mean is, let's say I have 5 students, and let's say this is a score at 100. So I have 31, 42, 65, 99, and 81. Okay, so let's do quick math on this. 2, 3, 5, 8, 9, 17, 118, 1, 4, 8, 14, 23, 31. Okay, that's your total. And let's divide by 5, 6 are 30, 1, 5, 3 is a 15.6. That's my average. Okay, so all right. Now the issue is the average is not helpful because it has clearly discounted this person and this person. So when you look at 63.6% average and you meet any of these 5 students and you think, well, the class average is 63.6, everyone's pretty close to that, but that's not true. Some people are quite far away. The only person who's kind of close to the 63.6 average is this individual here. Okay, so averages can sometimes be quite meaningless. So that's why it helps that there are 3 types of averages. They make sometimes the information a little less meaningless. The median is a different kind of average. The median is also an average. The median says that if I have, let's say we have 5 people here, let's put a 6th number. So I'm going to scratch this out. Let's put a 6th number here. Let's say 79. Okay. Actually, let's leave it at 5. It's easier to make the example. The median value is the middle value in a set of numbers. So let's say I have 5 students. The median value, the middle value, which means there's the same number of people below that value and the same number of people above that value, is actually 65. So the median, if the median were to be an average for my course, then my average is 65. Okay, so the median is different from the mean in the sense that the mean accounts for every number in that sample, and then you divide it by the total number present in the sample, and you get a mean score. The median is very simple. You split the entire sample into 2 halves if you can, if it's an even number. If it's an odd number, the number that's in the middle, that's your median value. Now, as simple as it sounds, there are formulas to calculate median, so you don't have to just kind of physically sort everything. You can go on to Excel and it'll do that for you. The mode is a different kind of average. Let's say, for example, this is these are the scores of, say, 10 of my students. One, two, three, four, 5, 7, 8. Okay. Now I have 10 students marked here. The average would be very misleading because these 3 scores are going to drop the average considerably. Okay. They would not represent anything because I really have very few students at an intermediate value. The median would also be somewhat meaningless because if you take the middle value, when so let's say we have 10, 1, 2, 3, 4, 5. So let's say these are all below that value anyway. If this is kind of the middle value, give or take, that's again going to give me a median value of, I don't know, about 45 or 50. Again, not representative. If you just look at the numbers of this 10 student class, it's easy for you to say the class does really well. There are a few students who are struggling, but overall the class does really well. There's a whole bunch of 90s and 80s. And wouldn't you want your representative number to actually speak to exactly what that observation is? That's where the mode comes in. Mode is the average that represents the bulk of the population. So your mode typically will focus on the largest number that form kind of a peak in the distribution of your numbers itself. So it might include all of that. It might include maybe these, but it'll probably not include all of these lower numbers. So it's much more of a representative average, especially when it's what we call a non-normal distribution. And if you think about it from a student perspective, the mode is the most meaningful when a class is generally doing well on a course with a few exceptions, or generally doing poorly on a course with a few exceptions. Okay, in those situations, what represents how the class does is not the brightest student or the poorest student. It's how the bulk of the class is doing. And that's where the mode comes into the picture. So when people talk about averages, it is very important to understand, are they talking about the mean, the median, or the mode? Because they all will mean different things depending on the context. Okay. That's that. Do we have any more slides? No, we're out of slides, but we'll go into Excel and we'll see how to make some of these graphs. Does anybody have questions so far? Steph?
Yeah, I'm a little confused as to how do you pick the median when there's like an equal number of data?
Oh, so that's why you use the formulas. So for
Oh,
example,
okay.
yeah, so there are formulas out there that let you do that. And also like when you pick your middle number, especially like for if I have 276, yeah, so this, I'll give you an example. It's easier when we use examples. Let me pull up the Excel file. Yeah, sometimes you can't get the middle number, especially when you have really, really large numbers. Then you just have the computer go ahead and pull a median number. So what I did on this particular sheet is I have distributed. So if you look at the original sheet, I'm just going to take you to the very first sheet. All of this data from all of the patients, so we're talking about, patient satisfaction with the anesthesiologist, it's scattered, your colors are all over the place and so on. Now, you see the repeat of the same kind of yellow, and I know I'm scrolling, so it's not the best. And if you notice this column, this is about males and females, if you can see this. And you can see it's split. You have both men and women. These are the ages, and you can see all the ages here. And there's no real pattern to it. So this is like the very first sheet that we used on the slides where we showed you the 30 students, right? It's a lot of data, but it's really not summarized in any sensible way, shape, or form. So it's in order to organize it, what Excel allows you to do, and this is a beautiful tool, is you can highlight an entire column, and then you can go to sort and filter. And what you can do is you can sort from A to Z, so it'll sort it alphabetically. But for example, if these different specializations are color coded, then I probably want to sort it by color. So I would just go to custom sort. It asks you if I want to expand the selection, which I do, which means I want it to cover the entire sheet. So I say sort, and then I can choose. So this is column D, if you can see here. I can say use column D, and I can sort by any column. I'm just going to choose D, and I can say by cell color. Okay. When I do by cell color, it'll go ahead and sort it out. Now I won't sort this out because I already did it on the next sheet. So I'm just going to cancel this. But if you go to the next sheet, now if you look at everything, they are all sorted by color. Well, kind of, not that it's not perfect, because even though the people who keyed in the data thought that they were using the same color, you'll see that exception here. These two are supposedly the same color, but there's a slight difference, which the human eye is not picking up, but the computer sees them as different. So it doesn't sort them together, it separates them. So you got to be careful when keying in data. Anyway, those are all distractions from the main point, which is you can sort the data by color, which is what I have done on this particular sheet. So now once all the data is sorted by color, what you can do is then you can further sort it by gender or by age and so on. And then you can put those numbers as tables and stuff. Now, if I wanted to total certain things, now these are easy totals, okay? They're all ones, so it's a yes or no. But it's if you have different numbers, then to total things is pretty hard. So for example, if I wanted to total this entire column, yeah, sure, I can go ahead and add each one. It may not be that much fun, but what you can do is you can put a formula into a box like this, and then you can just say, okay, you know what, this is what I want totaled, and you can highlight everything that you want totaled. So you go ahead and do that, and you go and hit enter, and magically it'll total these, and it'll tell you there's 17. Okay. You can do this. You can also do averages the same way. So you can go to the same auto sum thing. You can go and say, I want the average. And in this case, when you pick average, it's only doing the mean. So you can say average, and we'll pick the same again. And we'll hit OK. And it gives you an average of 1 because everything is 1 around here. Now, there are other things you can do. So let's say we spoke about mean, median, and the mode. Let's see if it allows us to do a median now. So I go here, it doesn't have it in immediate functions. So I go to more functions, and it says statistical, and you can type in the search box. I'm just going to say median. Yeah, it has median. Wonderful. So I say median, and I say OK. Now you have to remember that this is a very simplistic example, so it'll give you a median of 1. It's not, it's, you know, sorry, before I go there. So it pops up with this box when I choose median. And I just minimize the box so that I can highlight what I want. I go ahead and highlight this column and just expand that. Yep, so I want the median of those numbers. I say okay, and then it gives me a median of 1. This is the median value. I can do other statistical things like, well, you know, if I want the mode, I can go ahead and do the mode as well. Let's say more functions, you just type in mode. Statistical, let's go. Yep, there we go, there's a mode. So I say, okay. And the mode again will be 1 in this example. Go and highlight all of these. So in this case, because there are 17 samples, they all have a value of 1. Your mean, median, mode are the exact same. It's 1. But what it does, if you notice, is it makes, if you have a lot of numbers and you're not interested in counting how many are there, because you see how some of these columns have a 0 value, right? So you don't want to really sit and count each one of them. You can just highlight the whole thing. It'll let you use the mean, median, and mode to figure out which statistical average you want to use. There are other things it'll do as well, such as standard deviation. It'll do statistical tests such as a t-test or an f-test and so on. And basically it's the same idea. You highlight the columns you want and it'll plop that number into any other box that you like. Now, so that's the fun part. So you can do some basic descriptive statistics. Excel is not fantastic for doing any high-end statistical work. You need a specialized piece of software like SPSS or GraphPad Prism to be able to do all of those things. But you can do all of this basic stuff. Graphs are pretty straightforward as well. So for example, let's say, so this is what a summarized total looks like, right? So for all these different specializations that were color coded in the previous sheets, what I did is I made up totals. So I added all of them and so on. Now, for example, if I want to make a pie chart out of the distribution, so I go up to here and I don't put these values in because they're 5 and below, so they're not statistically significant. I'd go to insert, I would say insert a pie chart, and I go pie, and it inserts this, but it doesn't tell me what each of these things are. There's a very easy way to input that data. You just go, you go and right click and you say select data, and it picks up this series as series 1. But the labels, which we want all these specializations, are not there, so you can edit that. And what you can do is you can just go ahead and highlight these. And all of a sudden, cancel. Oh. Okay, and all of a sudden now you have a graph which the pie chart has different colored shape of the different slices of the pie, and it tells you what each one fits with. So this is the simplest way of making a pie chart. You can add labels and stuff once you go in. You can go ahead and so you can make it look like this. You can yeah, this is a little messy, so you can move things around. You can reduce the size of the image. You can move. Anyway, so if the same thing I wanted to represent as let's say a bar graph, so I can go ahead and delete this now. I could also represent the same thing as a bar graph. So I just go, it's called a column chart or bar graph, whatever you want to call it. Go ahead, and again, I would ask for it to split its, change how it picks its data. So the series are here and the labels would be these guys. Okay. And as you can see, it goes ahead and plugs all of that data in there. So it's a relatively straightforward way. Once you do it a few times, you get pretty good at making these different kinds of charts. I know I went through it very quickly, but if you have questions, we still have a few minutes so we can talk about that. Any of you have any questions? Something in the chat window. So that's a good refresher. Okay, very good. Super. Okay, so what we'll do now is this chapter is over. This is all about graphs and charts. Go through the questions at the end. I think we have, what kind of questions do we have? Yeah, I mean, we can go through questions next class. So next class on Thursday, for all those who are here and for all those who will be watching this recording, it's a review class for the midterm exam. Now, the way I do review classes might be a little different from other professors. So I'm not going to reteach the course that we've done so far, but it's an open session for you all to attend, to bring your questions to ask. Okay, so I am here for the entire 80-minute period on Thursday, but you have to come up with your questions. You ask your questions, obviously I will work with you and we will get you the answer, and that'll benefit not just you, but your peers as well. But it's not where I go through everything saying, well, this is important, study this. Everything is important. All the concepts we've spoken about are important. Your exam itself is very straightforward. There are, I think, of the 40 questions that you will have, there are maybe 3 or 4 questions that will take you a little bit of thinking. You'll have to do a double take, which will probably cost you more than the 1 minute per question, but most of the questions are like 5 to 10 seconds. Qualitative research involves numbers, graphs, phenomena, and something else. And even before you can read the question, you know the answer. Those are the kinds of, those are most of your questions. There are some questions which 3 or 4 questions, and that's basically to distinguish between the students who are really focused and the students who are kind of focused and the students who haven't been really very focused at all. So we want to be able to make that distinction. If everybody gets 100%, I don't think that's fair either. But I don't see anybody struggling to pass the exam or anything of that sort. You should all be able to do it really well. Okay. I have about 20 minutes more. Does anybody want to ask questions about the exam or about today's class or anything of that sort? Steph?
Yeah, you probably already mentioned this, but I have forgotten. So the final exam, is it cumulative? Is it the entire course, or is it just from like chapters 10?
Yeah, so that's what I was going to, I should mention too. So what we'll do is we will have, I think you have a total of 14 chapters. I can't remember if it's 13 or 14. I'm just looking at my textbook right now. Yeah, a total of 14 chapters. So chapter 1 through 7, chapters 1 through 7 for the midterm, and chapters 8 through 14 for the final.
Oh, okay. So I thought it was up until the ethics chapter for the midterm.
Yeah, I thought about that a little bit, and I said let's split it even and even because the number of marks is the same. So I said we'll go right down the middle. And the second thing is the chapters like if I included ethics as well, the meat of everything is finished in the midterm. The bulk, so students. The final exam becomes simply too easy because the rest of the stuff is actually very, very, very simple. So we'll have at least one little challenge, maybe the ethics chapter thrown in just for a little fun. Your final exam is going to be easier than the midterm. That's just how it is. Okay.
Okay, yeah, I like that better. So just double checking, it's 1 to 7 and then 8 to 14.
Correct. 1 to 7
Okay.
and 8 to 14. It's not cumulative.
All right, thank you.
No problem. Arthika says, no questions, but I enjoyed the TED Talks with Alice Kaufman from last class. Yeah, that's a great talk. I don't know if anybody else got to see it, but it's a really nice TED Talk. And if you read the article as well, which I had, it's quite easy to see why people went after Alice after that. And it was, basically she ran into the ethical challenges she had with keeping the data and all of that stuff. So anyway, well, you all have a wonderful day. Sorry, just to clarify, the midterm is taking place during our regular class time on Monday. Yes, so two things. The exam will be opened at 11. Now, I know that some of you will be having classes running into 11:30 or 11:20, right? But the reason I'm opening it up sooner is if anybody wants to come in to get signed up on the Lockdown browser or whatever it is, it might take a few minutes. I just did a test run, like pretending I'm able to change the settings on my D2L and pretend that I'm a student. So it took me about 6 minutes to get set up on the Lockdown browser. Okay, so I'm just giving everybody 30 minutes. I don't know how long it's going to take each person, but worst case scenario, it's 30 minutes. But if you get set up early, you have extra time and you can use that towards your exam. I'm not going to grudge anybody those few minutes that you have extra. That's absolutely fine. So it'll be open at 11, Carly. The exam technically starts at 11:30, but yeah, if you get set up earlier, go for it. And students with accommodations, they will be permitted extra time. Now, obviously, the exam doesn't cut you off at noon, at 12:10, but it does tell me when you submitted it in. So if you don't have a letter of any sort with me and you decided to take 80 minutes I'm not counting the time for the lockdown and the browser setup. I'm saying, like, instead of finishing at 12:10, you finished at 12:40, and there's no letter or anything, then I will have to take a few marks off because the exam is not intended to be very hard or anything. And it is not open book. Well, I mean, I guess you can do whatever you like, but if you have an electronic book, you won't be able to access it with a Lockdown browser. It's also going to be kind of minute a question. So you're better off knowing everything than depending on a textbook to help you out. Okay. Again, exam's not hard. Don't freak out. We will be meeting on Thursday. We'll keep it open for questions. Okay. All right. Well, have a good couple of days and we will see everybody on Thursday. All right. Bye.
Sure. Thank you.
Sure. No problem. Thanks. Take care. Bye.
Thank you. Take care. Bye.